All right, so we are going to be looking at given a transformations, write the function. So this is the opposite of what we had been doing. We're going to start with the names of the transformations. And end with the function itself. We had been working the other direction. We had started with the function and named the transformations, but now we're going to go the other direction. We're going to start with the names and write the function. So for instance, write the function of a graph that has been moved 3 spaces to the left. Oh, that's not what I wanted. So far, if we know that our original function that we're working with is f of x. That's our parent function. That is what things look like for the start. But we also know that if we have f of x, there's different places that our numbers can show up. We could potentially have a number in front of f for a stretch or a compression. We can have a number inside the parentheses for a horizontal translation, or we could have a number outside of the parentheses on the end for a vertical translation. So we need to figure out where this 3 spaces is going to end up in our function right here. If I'm moving my graph 3 spaces to the left, is that going to be in front of the f? Is that going to be inside the parentheses, or is that going to be on the end? It's going to be on the inside of the parentheses. Now, if I'm moving to the left, is that going to be +3 or is that going to be -3? +3, exactly. So my function here, we can write as f, oops, that's funky looking. F of x +3. And then close parentheses. And this right here would be my answer. I don't need to do anything else. Just like the problems you were seeing earlier, these are fairly straightforward. There's not calculations to do for most of these, like the identifying problems we've been seeing. But we're going the reverse direction as before. We're told what the transformations are, and we are writing what the function looks like rather than starting with the function and writing the transformations. Let's see another example here. Write a function that is compressed by a factor of 1/2 and moved down 7 units. So very similar instructions to before, but now we see that we have 2 different numbers that we need to take care of. We see that we've got compressed by a factor of 1/2, and we also have moved down 7 units. So we've got 2 places that numbers are going to be going here rather than just 1 place. If we think back to Tuesday, if we're compressing by a factor of 1/2, where is that 1/2 going to go? Is that going to go in front of the F? Is that going to go inside the parentheses, or is that going to go on the end? It's going to go in the front, exactly. So I know that I'm going to have my 1/2 out front. I know that I have my F in my parentheses with the X right here. But where is this 7 going to go? It's going to go on the far right side. Remember, if we're moving up or down, that's a vertical translation, which means it's going to be outside the parentheses on the end right here. So there's nothing inside the parentheses since there's no horizontal translation. And if I'm moving down, is that going to be +7 or -7? -7. I'm going to clear all these out. Write a function that moves up 8 spaces. So we've got one problem right here. Two, write a function that is stretched by a factor of 6. Write a function that moves 1 space right and 4 spaces down. And then lastly, write a function that is compressed by a factor 2/3, moves right 2 spaces, and up 5 spaces. Got to get that Oxford comma in there. All right. All right, so if we look at these, the first one here, let's do our general F, X. We're going to have space here in front of F. We've got a space inside the parentheses, and we've got a space on the end right here. Oh, it's frozen. All right, so we know that we only have one number here, and we see that it moves up 8 spaces. And whenever we're moving up or down, that's going to be on the end right here after our parentheses. So if I write this one out, this will be F of X. No number in front of the F, no number inside the parentheses, but now we're going to have +8 after the parentheses right there. This second one here we see is stretched by a factor of 6. Stretches and compressions are always the number that's in front of the F right here. So for us, this will have a 6 and then F of X. The third one, we see that we have 2 different numbers. We move 1 space to the right and 4 spaces down. So this is going to mean I have 2 numbers in my function. Inside the parentheses is always going to represent side to side. The outside of the parentheses is always going to represent up and down. So if I'm moving 1 space to the right, I'm going to have F of X minus 1 inside the parentheses. And then 4 spaces down will be minus 4 outside the parentheses here. Lastly, we see that we have 3 numbers on problem number 4. So we are compressed by a factor of 2/3. We're going right 2 spaces and up 5 spaces. So we have all 3 numbers. We need to figure out where they go. I mentioned before that stretches and compressions are always going to go in front of the f, and the same thing here. So if I'm compressed by 2/3, I would have 2/3 in front of my f of x. But since I'm also moving right 2 spaces, I'm going to have a -2 inside the parentheses with the x. And then I'm also moving up 5 spaces, so I'll have +5 outside the parentheses.